Hi, this is Stephen Barrett from Raton Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language, and this is the chapter overview for Stallings Chapter 3. This is also take 2 because take 1 was too long, and I may backfire and go the other way and maybe make this intro too short. But the idea behind the overview is just to give a high-level idea of a number of the topics, and then other videos will go into a little more depth. So one of the things we're going to look at in Chapter 3, which means there'll be a later video on it, is we'll take a look at the IAS computer, and then we'll look at this hypothetical machine, a very simple machine. The instruction set for the commands that the computer carries out, there's a sequence of 1s and 0s that tell the processor what to do. So if we want the processor to add, there's a series of 1s and 0s that we would get sent to the processor, and it would basically say this is what we want you to add. And if we wanted to subtract, there's a different set of 1s and 0s that would tell the subtract. And if we wanted to move data, there's a different set of 1s and 0s. So we're going to look at a hypothetical machine and its instruction set, and what we're going to do is we're going to trace how that processor, that hypothetical machine, will fetch and execute those statements. So we'll see that the command resides in memory. That'll be fetched and brought into the CPU, and then we'll trace through the execution of it. So one of the things that we're going to do is we're going to use a document that's going to show kind of over time. So we'll see, 1 unit at a time, how does it look after the fetch is done? At another unit at a time, how does it look after the execute is done? At another unit at a time, how does it look after the next fetch is done? And then at the next unit at a time, how does it look after the execute of that instruction is done? Then what we'll do is we'll take a look at the instruction cycle that's used now, which is a little more complicated. There'll be another video that's going to go through that instruction cycle. The elements, though, we talked about fetch. Here's the instruction fetch. The extra complexity is just figuring out, well, where is it in memory to fetch from? There is the execute, so there's the data operation that is the execute. And so what we'll look at in that other video is we'll talk about the decoding of the instruction, where the CPU figures out what to do, what operands to get, and then after it does the execution of the statement, does it actually have to send anything back to memory? And then it'll check for interrupts. And so a key thing, which we'll see later, is as the processor is going through all of these stages for one instruction, it is not interrupted. So kind of like it does an instruction and says, then it checks, is there anything left for me? Does another instruction, goes through the whole cycle, is there anything else for me? And so it'll keep doing that, doing the check at the end. But the idea is it's not going to be interrupted while working on that cycle. Something we're going to introduce in Chapter 3, we'll see a little more detail of in Chapter 3, but we'll see another chapter on it. It has to do with the bus. And the bus is just a data conduit. It's for sending data around the computer. And as we'll see later, there's now more than one bus. And although buses over time have changed the way that they were built, the general thing that buses do have, and they still have this now, are data lines. So the wires, I'm saying wire, but the paths in which the data is transmitted, the address lines. So if we're talking to memory, we need the address of where something is memory. We'll see later that memory is byte addressable. We'll see that in Chapter 4. And if we're talking to a peripheral device, then it might be, well, what sector are we actually writing to on the drive? And then the control lines is for coordination, or basically giving a command. So the CPU can give a command to an I/O device to do something, and it would be doing that through a control line. The other thing we'll take a look at in terms of the types of transfers are, and this actually has an effect on our language. So something can go from memory to the processor, from the processor to memory, from I/O to processor, from the processor to I/O. And the other thing is the processor can actually coordinate, or basically set up coordination between I/O and memory, so that the I/O can load the data directly into memory. One thing that is not listed here is memory to memory. And that's still true today. And for the assembly that we're going to be doing for this semester, we can't move from memory to memory, that we have to temporarily hold. So we actually, if we want to move something from one piece of memory to the other, we have to take the thing in memory that we have, or that we want to move, load it onto the processor. Then once it's on the processor, then we can then move it to the other place in memory that we want. So it's kind of like programming with handcuffs, because we're not going to be able to do that. Okay, so that's the overview for Stallings Chapter 3.